Continue with Theorem 2 of circles. The length of tangents drawn from an external point to a circle are equal. The statement says like that. We have a circle. We have a point outside the circle. Then from that point, we can draw two tangents. What we have to do, we have to prove that those two tangents are equal. To start with it, first you write down the statement. If we read the statement again, first what we have a circle. So that is given. What to do? Now first you draw the circle. After you draw the circle, what else we have? External point. That means a point outside the circle. You can take any point outside the circle. Here you can give any name, but let's name it as P. The center, let's name it as O. Okay. Then what to do from that external point? Remember we have tangents. So that means we can draw tangents. But when you draw, remember that the tangent should touch the circle only at one point. Okay. We can call it as point of contacts. Let's name it here as A. You can give any name of your choice. Okay. Not compulsory to give the name which I give. Then another tangent this way. See, it should touch the circle only at one point. Then this point of contact here, let me name it as B. So this is the given. They give us a circle, center O, radius we can name it small r. Then they also give us a tangent, a point from outside the circle. Here we name it as P. Then from P we have two tangent to a circle, PA and PB. So write that in the given. Okay. We have a circle. We name it C. O stand for center. R stand for radius. Then we take a point P which is outside the circle. Then we draw those two tangent PA and PB. Okay. From the point P to the given circle. Then remember what we have to prove. We have to prove that those two tangent are equal. So to prove, we can write the two tangent. What are they? From the point to the circle you look. Here we name it as PA. Here we name it as PB. So in order to prove, we have to do some construction. We already know from previous theorem that a radius and a tangent, they make an angle 90 degree. So let us join the center O to the point of contact. Here also, if we join from the center to the point of contact, clearly see this is a radius. So we join. Then we simply have a quadrilateral. We cannot do much with it. Also, let us join this one to form a complete triangle so that we can do something. Okay. So that means in the construction, what we do? We join OB, we join OA, we join OP. So write that in the construction. Okay. So let's start with the proof. Now we have those two triangles. What are those two triangles we have? PAO, PBO. Let's compare these two triangles. So you can write like that, okay? OAP, that means this one, and OBP, another one. Then if you look here, what happened? OA is a radius, OB is a radius. They are the radius of same circle, which means both are equal. So we can write that, okay? OA equal to OB because they are radii of same circle. Then if you look here, OP, from the name itself, okay? Here we have OP, here we have OP. So it present in both the triangle. It present here, it present in this one also. So we can write OP equal OP common side. Then we know radius is perpendicular to tangent from the previous theorem. So that means this angle here is 90 degree. Then here also same case. This is radius. This is tangent. So it will make 90 degree because we know radius is perpendicular to the tangent. So that means angle PAO equal to angle PBO. Okay, which make 90 degree because radius perpendicular to tangent. Now get this one is the side, this one is the side, this one is the angle. If you remember from class 9, when we have SAS, two sides are equal, one pair of angle are equal. Then in that case, we get the SAS concurrency, which means the two triangles are congruent. That means equal in everything. So the remaining side and the remaining angle will also be equal. But we don't need, which means this angle equal to this one to this one. But we don't need that. What we need only PB equal to PA. OA, OB, they already equal, we know. OP, PO already equal. So it means clearly that PA is equal to PB from the CP-CTC. Remember, corresponding part of congruent triangle are equal. So that's why we can conclude PA equal to PB. That means the tangent drawn from external point are equal. So just to wind up, remember they give us a circle with center O. Then we have a point from outside, we name it P. From this point, we draw two tangents which touch the circle at one point. Here we name the point of contact as A. Here we name it B. That is the given. Then we need to prove PA equal PB. So for that we need construction. Construction, what did we do? We join OA, OB, and then we also join PO. Okay. Then to prove, what did we do? We compare these two triangles. OA is a radius, OB radius. They are equal. If you look OP, we find it in this first triangle. We also find it in second triangle. So common side. Then we know radius, tangent, they make an angle 90 degree. Radius and tangent, they make an angle 90 degree. This is 90, this is 90, they are equal. So we get two sides and one angle, which means the triangle are congruent by SAS. So based on that facts, we conclude that the two sides are also equal because they are the corresponding part of congruent triangle. Okay, so with that we prove what the theorem said.